For example, if you notice oxygen, it's very often a combustion reaction, but that one we want to look for carbons and hydrogens. Here I only have hydrogen, so this will burn, but it's in fact a synthesis. I have an element, oxygen, reacting with another element, hydrogen, and it's going to form a single product. That's very typical for synthesis reactions. So in this case, there's different things that we could form. It has to have hydrogens and oxygens. The most common one that we would want to predict would be water, because we have H2O. I suppose you could get H2O2, which is hydrogen peroxide, although when we go in a lab and do this, we don't find that. But in grade 10, if you predicted hydrogen peroxide, H2O2, that's not a bad thing. But water is what we're probably going to form in this case. Well, it is what we're going to form in this case, H2O. Now, is it balanced? Let's check. I only have H's and O's. I have two H's on this side. I have two O's. I have two H's and only one O. Well, if two went in, two come out, which means now I have two, but I also have four, which means I need two of those to make four here. One oxygen reacts with two hydrogen to produce two water. So our one final example. Once again, we need to first predict the type of reaction. In this case here, I've got my different shapes. So this is going to be a double displacement reaction, because I'm going to have an ionic compound and an ionic compound. They're switching. Once again, just a reminder, we don't have states here, but these ones occur in aqueous solution, which means they're dissolved in water. And anytime things are dissolved in water and we come up with double displacement as our type, we have one more check. We have to see if it's neutralization. Neutralization is with an acid and a base. An acid is H plus in water, and a base is OH minus in water. Well, I noticed that if this was to dissociate, to separate in water, I would end up with H pluses, and I would end up with OH minuses. So in this case, this is going to be a neutralization. So that's not bad. That's the main type, but this subtype is in neutralization. So the proper answer would be neutralization. Neutralizations are an acid plus a base to make a salt. A salt, remember, not just table salt, a salt, and water. Well, water is an easy one. Water is going to be HOH or H2O. I prefer HOH because this H goes with those OHs to make water. A salt is whatever's left, so I have manganese in this case. Now, manganese has several charges. OH is 1 minus, and I have two of them, so this must be 2 plus. It's going with NO3. NO3 is always 1 minus, so in this case I have a 1 there, and in order to make that 2, I have to do brackets because it's 2 of those whole things. So I end up with manganese nitrate for a salt and water. So that's my formula. And now I need to balance. I have H's. NO3 is the same on both sides. I have manganese, and OH is the same on both sides. So let's count. I have 2, 1, 1, and 1. On this side I have 1 manganese and 2 nitrates. I have 1 H from here and 1 OH right there, which is why I want you to write it as HOH. Let's balance this. Hydrogens are going to go second last, but there's no oxygen, so that means they're last. So let's balance anything else. NO3, I had 1 on this side, but 2 came onto this side, so I must have 2. 2 NO3s, but that also means that the H's go with them, so I have 2. Manganese is fine. OH, I had 2 on this side, 2 need to come out over here. Got my plus. In order to make that 2, I have to put a 2 coefficient. 2 OHs, but that also means that 2 H's came with it. And now if I look, I'm 2 and 2, 2 and 2, 1 and 1, 2 and 2. This is balanced. 2, this is nitric acid, react with 1 manganese hydroxide to produce manganese nitrate and 2 waters.